In section 7.4, we're going to be approximating square roots. Now, while this may seem easy, this is actually a concept that a lot of students make mistakes on. So take notes and make sure if you have questions, write them down or put stars next to what you have questions on in your notes. So tomorrow in class or on Monday when we go over it, you can ask. Here is our key idea. A rational number, which is review for you, a rational number is a number that can be written as a ratio of two integers. Simply put, if you can take a number, any number, and you can write it as a fraction, it's a rational number. An irrational number cannot be written as a ratio of two integers. So if you can't write something as a fraction, then it's irrational. The square root of any whole number that is not a perfect square is irrational. The cube root of any integer that is not a perfect cube is irrational. Here's probably the most important thing to determine whether something is irrational. If you take a decimal and your decimal repeats or it terminates, it's a rational number. So here it says a decimal form of an irrational number neither terminates nor repeats. That means a decimal that basically goes on forever, but it does not repeat. That's an irrational number. All right, we are still in our key ideas. Real numbers. Rational numbers and irrational numbers together form the set of real numbers. So, here's what may confuse you, and I love this about math. There is so much out there that you don't know or you haven't heard about. Before we write anything down, I want to explain this to you. In math, there are real numbers and there are imaginary numbers. Real numbers are numbers that you've been working with since you were in elementary school, kindergarten, since you could count. Irrational and rational numbers together form real numbers. There is a whole nother realm of numbers called imaginary numbers. And you won't talk about those until probably 8th grade, maybe 7th, and definitely in high school when you get to Algebra 2. But imaginary numbers are a whole different set of numbers. So all you've dealt with are real numbers. So we're going to start with that as our title for this diagram. So, real numbers. So I'm going to draw a circle over here on the right. And we're going to title this, everything in this circle, as irrational. So that would, for example, be pi. Negative 2 pi. We could have negative the square root of 3 because 3 is not a perfect square. The square root of 2, that's not a perfect square. The cubed root of 7, that's not a perfect square. Now in this red, we're going to start with a small circle. Now, I want you in this circle to write natural numbers, or just natural. Now, I don't have enough room, so I'm just going to put natural. Now, natural numbers are like 1, 2, 3, and so on. Then, I'm going to make a bigger circle. If we add 0 to 1, 2, and 3, we now have whole numbers. So whole numbers are also natural numbers. But natural numbers are not whole numbers because 0 is not a natural number. So whole numbers would be adding 0. When we start adding negative numbers, such as negative 1, negative 2, negative 3, these are then called integers. But notice we haven't started talking about ratios yet. Ratios are what make rational numbers. So then rational numbers are like 1/2, negative 2/3, 2 and 25/100 written as a decimal, 0.3 repeating. Those are all rational numbers because you can write them as a fraction. So real numbers make up both of these bubbles of rational and irrational. In example 1, I've made a chart to classify each number. And then we're going to explain. So we're going to classify it by telling you, like, are they natural, whole numbers, integer, rational, irrational. And then we're going to have reasoning. So let's look at the square root of 12. Is the square root of 12 irrational or rational? It's going to be irrational. Why? Because 12 is not a perfect square. B is negative 25 hundredths repeating. Negative 0.25, and I forgot the repeating sign. What is that? Well, if you look, it's not natural, it's not a whole number, it's not an integer, therefore it's rational. Why is it rational? Because rational numbers can repeat. So you could say is a repeating decimal. So it's a repeating decimal, therefore it's rational. Next one, negative square root of 9. Now this one, what is the square root of 9? This actually is negative 3. And what do you know about negative 3? It's a rational number, but what else is it? It's an integer. And why? Why is it an integer? Because negative 3 is an integer. Or you could say because negative square root of 9 is an integer, or because it's negative 3. 72 divided by 4. Well, that's a fraction, but what is 72 divided by 4? Well, our reasoning is because 72 divided by 4 is equal to 18. Well, 18 is rational. 18 is also an integer. 18 is also a whole number. And 18 is also a natural number. And the last one is pi. Pi is irrational. Why is pi irrational? Because if you write it as a decimal, it does not do one of two things, or either of two things. It does not terminate or repeat. Therefore, it's irrational. Example number 2. Estimate the square root of 71 to the nearest A integer and B the nearest tenth. So the first thing we're going to do is figure out what integer is closest to the square root of 71. So what I always like to do is I always make like a little table. And we're going to start by just writing down some numbers. Now, if you're thinking here, like what number times itself will give us close to 71? Well, for example, if you just pick 7, the square of 7 is 49. Well, then go to the next number, 8. 8 times 8 is 64. 9 times 9 is 81. Well, you know, or you should know, that 71 is between 64 and 81. Well, is it closer to 8 or is it closer to 9? Well, 71 is closer to 64 than it is to 81. So we know that the square root of 71 is closer to 8. So the nearest integer for part A is 8. B then is to the nearest tenth. Well, we know that our numbers, it's going to be between 8 and 9. Well, because it's 8 and 9, and now we're doing tenths, let's write down some tenths. So I'm just going to pick some numbers here. 8.3, 8.4, 8.5. Now, why don't I have to go any higher? Because you know that 71 was closer to 8 than it was to 9. So you're going to choose the lower end of the 8s. So if you square 8.3, that gives us 68.89. 8.4 squared gives you 70.56. 8.5 squared gives you 72.25. Well, 71 is between 8.4 and 8.5. Well, 71 is closer to 70.56. Therefore, to the nearest tenth, the square root of 71 would be closest to 8.4. Example 3. The radius of a circle with area A is approximately the square root of A divided by 3. The area of a circular mouse pad is 51 square inches. Estimate its radius to the nearest integer. Well, it says the area is approximately the square root of A divided by 3. So we know the area of a circular mouse pad is 51 inches. So we're going to plug in 51. Oops, let me erase that here. The square root of 51 divided by 3, which gives us the square root of 17. We want to estimate its radius to the nearest integer. So the square root of 17, if you did it, you can use a calculator, but if you did, for example, the number 4 and 5, 4 squared is 16, 5 squared is 25. Well, 17 is closer to 16, therefore, the radius is going to be about 4 inches. So if you rounded or estimated to the nearest integer, it would be about 4 inches. Our last example is example 4, another real-life application. So the distance in nautical miles, you can see with a periscope you can see here is sticking out of the water, is 1.17 times the square root of h, where h is the height of the periscope above the water. Can you see twice as far with a periscope that is 6 feet above the water than with a periscope that is 3 feet above the water? Explain. So the first thing you need to write down is, if you don't want to write down this entire thing, we're on page 312 in the 8th grade book. So we have two things to compare. We have 3 feet above the water, and we have 6 feet above the water. Whenever you have things you have to prove or explain, stay organized. So I always make a little chart or a table. So we know that 1.17, and let me redo that here, 1.17 times the square root of h. Well, the height is the distance above the water, so the first one is going to be the square root of 3. So if I take the square root of 3 times it by 1.17, that gives me approximately 2.03. If you're 6 feet above the water, that's 1.17 times the square root of 6. And that gives me approximately 2.87. So, here's my question. Can you see twice as far with the 6-foot periscope than you can with the 3-foot periscope? Well, if you divided these two, 2.87, divided by 2.03, remember, we always want to prove our answer. That gives me approximately 1.41 times farther. So, is it twice as far? The answer is no, it's not twice as far. And why? Explain. You already did it. You proved it mathematically right there. That mathematically it's not 2 feet or more. It's not twice as far.